Hello and welcome. So we have ourselves some intersecting chords here. We have the arc measures, and we're really just trying to find x. So first off, first thing you have to know is how do intersecting chords relate to the arc measures in the angle? Well, first off, let's look at what we have. We have this arc measure, we have this arc measure, and we have this angle. And you'll notice that if you were to draw a line, you notice that they all hit along that same line. And this is really important. This tells us that we have the property that chords follow, meaning that our angle that is in line with our two arcs equals 1/2 of our major arc plus our minor arc. Okay, and this is a property of your chord. So for example, if we had this chord and that not chord, if you had that arc and the other arc, right? So the arc from G to E and the arc from B to C. That means that if you were to use this property, you could find the angle in red right there. Okay, or if you know the angle in red in one of the arcs, you could solve for another, right? Any of those, vice versa. Okay, so as we're looking at that, I'd say, okay, whew. Well, once we know this property, we know that our angle, which is 7x plus 11, equals 1/2 of our major plus minor arcs. Well, the major arc is 4x plus 19. The minor is 6x plus 9. Now, you may be wondering what this vocabulary I'm just chucking out here, right? Major and minor means. A major arc is generally considered to be an arc that is larger than 180 is usually considered to be a major arc. Now, major arc versus minor arcs, depending on who you ask, frankly, as a mathematician, you're going to see potentially different definitions coming up. Now, what I really use to define major versus minor arcs is we're just talking about this arc, it's larger than this arc. Okay, so I'm going to call this one is your major arc. This one I'm going to call the minor arc. And the only reason for that is because the one on the right is larger than the one on the left, and that's why I'm using the major versus minor vocab right there. Okay, so don't let the wording trip you up too much. It's essentially just the angle equals 1/2 of the bigger arc plus the not as big arc. You're just adding them together. Okay, and there you have it. So now we have the equation set up. Now it's just a matter of solving for x, right? We have more than one x in our equation. Your goal is to combine all of these x's together if you can, right? You want to get all of the x's on one side. So let's start working with it. I'm going to combine my numbers first and see if I can easily take care of that 1/2 than distributing a fraction. So let's add our like terms. 4 plus 6, we have 10x. 19 plus 9, we have 28. And then equals 7x plus 11. Well, 10 and 28, those can't combine because this x here makes sure that that's not a like term, right? Only x is combined with x's, numbers with numbers. So then this is the point where you have to take care of the 1/2 here, right? So you could distribute the 1/2 through, or you can multiply both sides by 2. Where we have 10 and 28 as both even numbers, I'm actually just going to distribute this 1/2. So that means we take half of 10, right? 1/2 times 10, that just means 10 divided by 2. That is 5. So we have 5x. 28, half of 28 is 14. And there you go, right? Now you've distributed that through. Because that's 28 times 1/2. In other words, 28 over 2, 14. Okay, and then that equals 7x plus 11. Okay, from here I'm going to subtract 5x. If your goal is to get all the x's to one side, I personally like my x's to be positive, so I'm going to move the right 5x to the left by subtraction. Okay, those will simplify with each other, and if we're moving the x's to the left side, we'll launch our numbers onto the other. So I'm going to move the 11 over. It's addition, so move it with subtraction. And then 7 minus 5 is 2. So we have 2x, and then equals, on the right side, 14 minus 11. 3. And then from there, keep solving for x, right? That's being multiplied by 2. Undo multiplication with division and divide by 2 both sides. So then we get x equals 3/2. Now, does this simplify any further? No, right? 3 and 2 don't have any more common numbers, so there's nothing more we can really do on this one. If we had, for example, 6/4 as our final answer, you'll notice that 2 goes into both top and bottom, right? 2 goes into 6 3 times, into 4 2 times, right? Be very careful. Make sure that you are solving and simplifying if it asks you to, right? This one you will need a simplified fraction, right? That's what it means by exact answer. Make sure that you are simplifying it, because if you don't, it will mark you wrong. So keep an eye on that. So x is 3/2. Shibuya, you're done, right? Because if you try plugging 3/2 in, you'll notice that it comes back positive in all accounts. You're good to go, right? Because lengths can't be negative. Just do a quick double check on that one. Alrighty, and that's all there is to it. You're done. Thanks for watching.